Okay, so in this question, we have three waves traveling along a string. The phases for the waves are given by 2x minus 4t, I named this phi A, 4x minus 8t, I named this phi B, and 8x minus 16t, I called this phi C. The question is which phase corresponds to which wave in the figure. So if we look at the figure, we can see this is wave 1. I have marked one full wave here in red, and this is wave 2. It's just a single oscillation with a very large wavelength, and this is wave 3, intermediate between waves 1 and 2. It is marked in green. One oscillation of wave 3 is marked in green. Now, the first thing to notice is that on the x-axis we have a displacement instead of time. And this means that the peak-to-peak position will give us the wavelength lambda and not the period t. So for this full wave here, which is wave 3, this is actually lambda 3. And for this wave here, this is lambda 1. And for the last wave, this whole distance is lambda 2. Now, we can relate the phase that we have to the lambdas that we are seeing here. We can see that lambda 2 is the greatest, followed by lambda 3, followed by lambda 1. Now, if we look at our phases, we know from the wave equation that the general form is kx minus omega t. So we can use this form to reduce k. So we know that k in phase A is 2, k in phase B is 4, and k in phase C is 8. And from k, we can relate this to the wavelength. We know that k is equal to 2 pi over lambda. So 2 pi over lambda A is going to be 2, 2 pi over lambda B will be 4, and 2 pi over lambda C will be 8. And this means that lambda A is going to be the largest, followed by lambda B, followed by lambda C, which means that these correspond to lambda 2, lambda 3, and lambda 1. So for wave 1, we have phi C. For wave 2, we have phi A. And for wave 3, we have phi B. And we can write down their values. So this is 8x minus 16t, this is 2x minus 4t, and this is 4x minus 8t. So we can see that the one with the highest k is the one with the lowest wavelength, and the one with the lowest k, which is phi A, is the one that has the largest wavelength, which corresponds to wave number 2 in our case.